All right, graph one complete period of y equals -1/2 sine of 2 pi x plus 5 pi. All right, so this is going to be just a variation of the graph of y equals sine of x. Okay, remember we call this the base graph because there's no transformations going on. Okay, so just a quick little sketch of sine of x. We always start at 0. Okay. Of course, we can go in both directions, but we know that the amplitude goes from -1 to 1. We start at 0, and one complete period here, right, that's going to be 2 pi. So then what's going on with this guy here, right? Well, we know that these are variations on the a times the sine of bx minus c. Okay, so the a, b, and c are all going to affect the shape of the graph, okay? So first thing we should do is just identify what the values of a, b, and c are, right? In this case, a is -1/2. B is the coefficient of x, which in this case is 2 pi. And c is negative of 5 pi, so -5 pi. Okay. So then the amplitude, right, the amplitude is given by a. Right? It's actually the absolute value of a. It doesn't really matter, right? It's 1/2. So that just means instead of going from -1 to 1, right, we go from -1/2 to +1/2. Okay. The negative just tells us that we're going to reflect the graph across the x-axis. Okay, so if you say the amplitude is -1/2, it doesn't really make a big difference. Okay, now the period, which is denoted by the capital letter T, that is 2 pi divided by b. Right, so we'll just plug the b value in here. 2 pi divided by 2 pi. Wait a minute, that's just equal to 1, right? So that's the period of this function. And the phase shift is c over b. So in this case, the -5 pi over 2 pi, right? That's actually just pi's cancel out, so -5 over 2. Remember, the negative tells us that we're going to shift this to the left. Okay. So how do we draw this guy? Right? The first thing is we always do the phase shift first, right? That's the horizontal shift. Where does this graph start? It starts in this case at -5 over 2. Okay. And your next thought would probably be, okay, I need to draw this. I need to go up, down, and then start, and then end back over here. But you got to be careful, right? It's negative. So instead of going up, right, this graph should start going down, right? So we'll go down, come back up, and then we'll end back right where we started. Okay, this is one complete period. Okay. Now, of course, the graph does continue on forever in both directions, right? Okay. That's the wave that we got here, right? But what we're doing is we're just going to figure out one complete period, which is from here to here. Okay? Of course, you can do another period. You can draw this period or this period here, right? It doesn't really matter. Okay? But we're just going to do this just because I know that we started at -5 over 2. Okay? So now we want to find these remaining 4 points. Okay? We know that this is -1/2 and +1/2 here. Okay? So what are these points going to be, right? Well, okay, the period is 1, but that does not mean that this is the point 1, which doesn't make sense, right? It means that the length, the distance from here to here, that is 1. Okay? So, okay, I know I start at -5 over 2. I just add the period to that, which is 1. Okay? Of course, we add fractions by getting the LCD, so that's 2 over 2. So we get -3 over 2. Okay? So that's this point right here, right? This point here is -3 over 2. All right, now what about these guys? Well, we always get the middle piece, right? So we'll get this point right here, which is the average of these two, right? So we want to take the -5 over 2 plus -3 over 2, and then multiply that by 1/2, right? So this is -8 over 2, which is -4, times 1/2. Right, that actually just gives us -2. So that's this point right here, right? This point is the average of these two guys. We get -2. And then we can do the same thing to find these guys, right? To find this point, we'll add the -5 over 2 plus -2. And that'll give us this point right here. Okay? So -5 over 2 plus -2. Once again, we want to get the LCD because we're adding fractions together. So that's -4 over 2. Okay? So -4 over 2. So -5, let me rewrite that, -4 over 2. We get -9 over 2. Okay, but once again, we have to multiply that by a half. So this point here should be negative 9 over 4. And negative 9 over 4 here. And then similarly, to find this point, we add these two together and we'll divide by 2. Remember, dividing by 2 is the same as multiplying by a half. Okay, so we'll, let's see, running out of space here, so I'll take negative 2 plus negative 3 over 2. Once again, adding fractions together, we need to LCD. So we get negative 7 over 2, but once again, multiply that by a half. So this point here should be negative 7 over 4. And there we go. We've drawn one complete period. Once again, you could have used this period, or you can use this one right here. It doesn't really matter. But I just like to use the one where we start with. So we started at negative 5 over 2. We went down in this case, not up because of the negative, and we found these points.